11.2 Part F, Relationships between two categorical variables. Two-way tables can arise in several ways. The music and wine experiment compares 3 music treatments using independent groups of observations. The phone use and political party affiliation observational study compared independent random samples from the cell-only and landline user populations. In both cases, we are comparing the distributions of categorical variable in several populations or treatments. We use the chi-square test for homogeneity to perform inference in such settings. Another common situation that leads to a two-way table is when a single random sample of individuals is chosen from a single population and then classified according to 2 categorical variables. In that case, our goal is to analyze the relationship between the variables. The next example describes a study of this type. A study followed a random sample of 8,474 people with normal blood pressure for about 4 years. All the individuals were free of heart disease at the beginning of the study. Each person took the Spielberg Trait Anger Scale test, which measured how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease. This includes people who had heart attacks and those who need medical treatment for heart disease. Here is a two-way table that summarizes the data. Calculate appropriate conditional distributions in proportions to describe the relationship between anger level and coronary heart disease status. So since we are interested in whether angrier people tend to get heart disease more often, we can compare the percents of people who did and did not get heart disease in each of the 3 anger categories. So we would look at the low anger category first, and we would look at those that did get chronic heart disease versus those who did not get chronic heart disease. And so for heart disease, we would get 53 out of 3,110, and we would do no heart disease 3,057 out of 3,110. We would do the same thing for all 3 levels, and we would get these percentages. So of those who had high anger, 96% of them did not get chronic heart disease, while 4% did. Moderate, 98 did not, while 2 did, and low anger, again about 98%, did not get chronic heart disease, coronary heart disease, while about 1.7% did. Make a well-labeled graph that compares the conditional distributions in Part A. So for this, we can just graph one of the categories. So we are graphing the percent that had coronary heart disease. So we can see low anger, moderate anger, and high anger, what happens to the percent that has coronary heart disease. Write a few sentences describing the relationship between the variables. So if we look at this graph, there is a clear trend that as anger scores increase, so does the percent who suffer heart disease. A much higher percent of people in the higher anger category develop coronary heart disease at 4.3%, than in the moderate level, which is 2.3%, and the low anger category, which is only 1.7%. We often gather data from a random sample and arrange them in a two-way table to see if categorical variables are associated. The sample data are easy to investigate. Turn them into percents and look for the relationship between the variables. Is the association in the sample evidence of an association between these variables in the entire population? Or could the sample association easily arise just from the luck of random sampling? This is a question for a significance test. Our null hypothesis is that there is no association between 2 categorical variables. The alternative hypothesis is that there is an association between the variables. For the observational study of anger level in coronary heart disease, we want to test the hypotheses that the null hypothesis is there is no association between anger level and heart disease in the population of people with normal blood pressure. And the alternative is that there is an association between anger level and heart disease in the population of people with normal blood pressure. No association between two variables means that the value of one variable do tend to occur in common with values of the other. That is, that the variables are independent. An equivalent way to state the hypotheses would be anger and heart disease are independent in the populations of people with normal blood pressure, and the alternative would be that anger and heart disease are not independent in the population of people with normal heart blood pressure. As with the two previous types of chi-square test, we begin by comparing the observed counts in a two-way table with the expected counts if the null hypothesis were true. So the null hypothesis is that there is no association between anger level and heart disease in the population of interest. If we assume that the null hypothesis is true, then anger level and heart disease are independent. We can find the expected cell counts in the two-way table using the definition of independent events that we had in Chapter 5, which says we know that they're independent if the probability of A given B is equal to the probability of event A. Let's start by considering the events of coronary heart disease and low anger. We see from the two-way table that 190 of the 8,474 people in the study had coronary heart disease. If we imagine choosing one of those people at random, so the probability of selecting someone who has coronary heart disease is 190 out of the 8,474. Because anger level and heart disease are independent, we know that the selected individual in low anger gives us no additional information about the chance that this person has heart disease. So we know that the probability of selecting someone who has coronary heart disease given that they have low anger would just be the same as selecting someone who has coronary heart disease, which is 190 out of the 8,474. Of the 3,110 low anger people in the study, we would expect that we're going to take the probability of having coronary heart disease in the entire population. We're going to multiply it by the sample size of people who have low anger, and we would expect that we would have 69.73 of the people who have low anger to get coronary heart disease. We could also write this as the same way we did earlier. You multiply the row total and the column total and then divide it by the total for your entire table. You can see that the general form we developed earlier for the test of homogeneity still applies. So our expected count, we can do row total times column total divided by the table total. So we find the expected counts for all the cells in the two-way table in a similar way. So we would, for each of these, row total times column total divided by the table total, and this would tell us how many we expect to have in each of the categories. So for moderate anger and coronary heart disease, we expect to have 106.01. For high anger and coronary heart disease, we expect to have 14.19, and we would do the same thing for no coronary heart disease as well. If the random large sample size and independent conditions are met, the chi-square statistic calculated from the two-way table can be used to perform a test of that the null hypothesis is there is no association between two categorical variables in the population of interest, and the p-value for this test come from a chi-square distribution with our, remember, degrees of freedom in this case will be the number of rows minus 1 times the number of columns minus 1. This new procedure is known as the chi-square test for association/independence. So if we're using the chi-square test for association or independence, suppose that the random large sample size and independent conditions are met. We can use the chi-square test for association or independence to test our hypotheses that there is no association between two categorical variables in the population versus there is an association between the two categorical variables. Or we can write our hypotheses as two categorical variables are independent versus two categorical variables are not independent. Either set is fine, but make sure you just stay consistent. So if you're talking about an association in one, you're going to talk about association in the alternative. And if you're talking about independence in the null, you need to talk about independence in the alternative hypothesis as well. You're going to start by finding the expected counts, then calculate the chi-square statistic. So just like we did with all the other chi-square tests, once you've had the expected counts, you're going to do the observed value minus the expected squared divided by the expected. You're going to do that for each of the categories, and then you're going to add them all together, and that'll get you chi-square statistic. Then you need to find your degrees of freedom. Again, your degrees of freedom is the number of rows minus 1 times the number of columns minus 1. And the p-value is the area to the right of the chi-square under the corresponding chi-square density curve. So you do need to check those conditions. You still need to check the random condition. It says data comes from a random sample of randomized experiment. You need to have a large sample size, which means all the expected counts need to at least be 5. And you need to check for independence. So individual observations are independent. When you have to sample without replacement, make sure you check that 10% condition. So here is a complete table of the observed and the expected counts for the coronary heart disease and anger study side by side. Do the data provide convincing evidence of an association between anger level and heart disease in the population of interest? Carry out an appropriate test to help answer this question. So first, we're going to start with our state. Remember, in the state, you need to give the null and alternative hypotheses, and you need to state the significance level. So we want to perform a test of the null hypothesis is there is no association between anger level and heart disease in the population of people with normal blood pressure, versus the alternative hypothesis that says there is an association between anger level and heart disease in the population of people with normal blood pressure. And we're going to go ahead and let our alpha level equal 0.05. Next is our plan. In your plan, you should state what method you're going to use, and you should check your conditions. So we should carry out a chi-square test for association or independence if the conditions are met. Now to check our conditions, we have random first. They tell us in the problem that the data come from a random sample of 8,474 people with normal blood pressure. Next, you're going to check for large sample size. If you already have your expected counts done, all you have to do is make sure all of those expected counts are at least 5, and then the large sample size has been met. And then you need to check for independence. Because this is sampling without replacement, we do have to make sure the 10% condition is met. And we can assume there are 84,740 people in the entire population that have normal blood pressure, so we are okay for this. Knowing the value of one person, so knowing one person's coronary heart disease, whether they have coronary heart disease does not tell us anything about anyone else, so the individual observations are also independent. Next is the do. This is where you're going to do the calculation. Remember, you're going to do it observed minus the expected squared, all over the expected. Then you would go to the next one, observed minus the expected squared, all over the expected, plus ... Remember, you don't have to show every single step of this. You can just show like the first two and the last one. And then you can give the chi-square value of 16.08. To find the p-value, you have to find the degrees of freedom. Now we have 2 rows, so we have 2 minus 1. We have 3 columns, so 3 minus 1, or 1 times 2 gives us degrees of freedom of 2. You can look it up on your table, and it's going to give you a p-value of, you can estimate where the p-value is going to be located, or if you put it in your calculator, you're going to get a p-value of 0.00032. Now to calculate this on your calculator, you will need to use the chi-square test. Instead, if you will input all your observations into list 1 and your expected counts into list 2, you can then hit stat, go over to test, and select chi-square goodness of fit test. You will put in your degrees of freedom, and then you can go ahead and calculate. The last thing you need to do is your conclusion. So because the p-value of 0.00032 is less than 0.05, we have sufficient evidence to reject the null hypothesis, and conclude that anger level and heart disease are associated in the population of people with normal blood pressure. Now let's check our understanding. Many population businesses are franchises. Think of McDonald's. The owners of a local franchise benefit from the brand recognition, national advertising, and detailed guidelines provided by the franchise chain. In return, he or she pays fees to the franchise firm and agrees to follow its policies. The relationship between the local owner and the franchise firm is spelled out in a detailed contract. One clause that the contract may or may not contain is the entrepreneur's right to an exclusive territory. This means that the new outlet will be the only representative of the franchise in a specific territory and will not have to compete with other outlets of the same chain. How does this presence of an exclusive territory clause in the contract relate to the survival of the business? A study designed to address this question collects data from a random sample of 170 new franchise firms. 2 categorical variables were measured for each franchisor. First, the franchisor was classified as successful or not based on whether or not it was still offering franchises as of the certain date. Second, the contract each franchisor offered to a franchisee was classified according to whether or not the exclusive territory clause. Here are the counts, and the data is arranged in a 2-way table. Do these provide convincing evidence of an association between an exclusive territory clause and business survival? Carry out an appropriate test at an alpha equals 0.01 level. So once again, we're going to start with our state. We're going to give our 2 hypotheses and our significance level. So we want to perform a test of the null hypothesis is there is no association between territory type and success or not in the population of franchises. And the alternative is there is an association between territory type and success or not in the population of franchises at the alpha equals 0.01 level. Next is when we come up with our plan. So we're going to use a chi-square test of association or independence if the conditions are met. So the first condition is that it's random, and it does tell us this is a random sample of franchises. Next, we need to check the large sample size. So we need to find the expected counts. Remember to do that. You're going to do the column total times the row total divided by the total for the table in each of the categories. And as you can see, each of those are at least 5. So the large sample size is met. And then you need to check independence. We can assume there's more than 1,700 franchises in the United States, so the 10% condition has been met. Next, we need to do the calculations. So remember, you do the observed minus the expected squared all over the expected. And then you would do that for each category, observe minus the expected squared all over the expected. If we do this for all the categories together, we are going to get a chi-square of 6.02. To find that p-value, remember you're going to do degrees of freedom, is the number of rows minus 1 times the number of columns minus 1, which in this case will just give us a degrees of freedom of 1. Now from this point, you can go to your table, go to degrees of freedom of 1, go over until you find a chi-square of 6.02, then look at the top of the row and see where our p-value falls. Or if you do the calculation on your calculator, you will find that the p-value is 0.014. So the last thing we need to do is write our conclusion. Since the p-value of 0.014 is greater than our alpha of 0.01, we fail to reject the null hypothesis. We do not have enough evidence to conclude that there is an association between whether franchises have an exclusive territory or not and whether they are successful or not.